Welcome to this video on software operation and maintenance. As part of the CISSP exam, you are expected to understand operation and maintenance as it pertains to the software development lifecycle. Operation and maintenance is pretty straightforward. It's just making sure that the software application security provides its intended function or purposes. And what we mean by operation and maintenance, or O&M, is when the software has been deployed, it's now running in production, or it is in an operation environment. And now we need to make sure that it stays up and running and stays secure. So what we have to do is focus on ensuring that the software remain operational and prevents any kind of compromise to confidentiality, integrity, or availability. The main way that we do that is through software patch management. So once the software application is in operation, typically there are going to be flaws. There are going to be things wrong with it. And eventually it's going to need to be patched. And it must be part of an overall patch management policy to address those flaws or those bugs in those software applications. We should also follow a strict and consistent process for identifying and installing these patches or fix actions. The reason this is important to be consistent is because the software application is in CRUD or it is in OPs. So it's running, customer are using it, and the organization is depending upon it. And this is very important to know for the CISSP exam. So the patch management process you should be familiar with. All start with evaluation. So the patch management process you should be familiar with all start with evaluation. We want to identify patches and determine the risk to the system. The risks to the system is going to determine how important this patch is. So if we just get a common patch, maybe it's just a simple web browser patch or something like that. If it is not a web browser that affects us, let's say a patch comes out Mozilla Firefox, but we don't use Firefox, then the patch is irrelevant. The risk is not existence. But if we use Google Chrome or we use Microsoft Edge or something else, if we are using those and those have a patch, now we need to identify what does that patch solve. Does that patch solve a security risk? Does it solve a functionality problem? Is it because it added new fonts or because it added some new feature? That's not really a security risk or an operational risk. But if there is a cross-site scripting vulnerability, that increases the security risk rapidly. So that means that we need to pay attention to this patch. It becomes a critical install at this point. And now we need to go ahead and move it to the test. So now we want to evaluate this patch in a test environment in some way to look for any kind of negative impacts. So when we install this patch, does the browser stop working? Does the certain feature get disabled? Does it change the security control baseline? What happens when we install this patch? If there is a no negative impact, then it's not a big deal. Then we move to the approval process, where we take it to the stakeholders. And typically this is going to be done as part of the configuration management. We would take this to the change control board. We would ask the authorization to install. The subject matter expert would take a look at it, and once the CAB approve this, now we have to move into rollout or deployment. In this case, we would roll the patch out, install it on all the production hosts that are necessary, and then once that's done, we want to verify that everything has been installed, it's working properly, and we also want to verify that nothing has regressed in terms of security. And we want to move through this process as fast as effectively or efficiently as possible. So this needs to be laid out as part of the configuration management plan. Now, as part of the step 5 of this process, I mentioned regression. So what is regression? Software can regress, meaning a patch or a bug fix can cause unwanted changes, regress the configuration, or regress the security baseline in the software application. And it could be based on vendor's fix action. It could be based on a configuration setting and so on. As part of the verification process, we want to perform regression testing to make sure that whenever we install the patch, that it doesn't open up new attack vectors and it doesn't create new vulnerabilities, that we don't have new threats. Now, because of this patch, and if you ever patched a system before, you know sometimes patches can cause unwanted damages. You can install a patch, it reconfigures the system. That means it doesn't open new attack vectors, that it doesn't create new vulnerabilities, that we don't have new threats. Now, because of this patch, and if you ever patched a system before, you know sometimes patches can cause unwanted damage. You can install a patch, it reconfigured the system, and now the system not working like it once did. So there might be a bug fix, and in that bug fix there's feature configuration change, and now all of the sudden you have new feature, and now you have to research those to determine, hey, are these security relevant? And that's why we perform that testing. And early testing in step 2, we would test it and determine what would happen, and that hopefully eliminates the possibility of a regression happening in the system. Now, there is a variety of regression tests that we can perform as part of this verification. We can perform a unit test where we look at individual functionality. If we patch something that was focused to the individual functionality, we would target the source code if possible to determine if the software is ready or not to continue operation, or it's ready to go ahead and be verified and accept it. We can perform a functional test where we are ensuring that the software meets operational requirement. Now, once we have made that patch update, does the system still meet the functional requirement or the operational requirement that we have set forth? If not, then we need to roll the patch back, because that baseline was approved by the change control board under the configuration management process. We can also perform an integration test, which makes sure that the software is still interacting properly between different technologies. And then once we patch it, maybe something breaks, maybe a new API feature comes in, and then that breaks the API connection because the keys needs to be reinstalled. But an integration test would help us discover that. And then obviously we can do a security test where we verify that the software meets security requirements. Now, by far and away, this is probably the most common regression test that we will do. Is we will verify, either we will do a vulnerability assessment, and maybe we just do a quick security assessment to check various controls. It really depends on your organization and also your compliance requirement. But in this case, we would test it, make sure that it still meets the security requirement, and then go ahead and approve the changes. Now, one of the most effective way to do this is to implement this via DevOps. So to create a CI/CD, continuous integration, continuous delivery pipeline, and that way we are checking everything throughout the entire process. So if you recall back to the DevOps and the DevSecOps video where we talked about infrastructure as code, security as code, those kind of things, this is when we would build that in. So in this case, we have our version, which is our current baseline. Then once the patch has been identified, had been evaluated, and we know we need it, then what we would do is we would move it into build, where we install the patches onto whatever host, and that would be within the test environment. So then we would do a unit test or whatever we would do here. If we have a separate test environment or integration environment, we can move them along in this path, and then we can automate the test right here. Maybe we want to do an automated security test, maybe a security scan, a vulnerability scan, something like that. Or what if we have some kind of SCAP scan, where we are doing a control scan to make sure that everything is set correct and nothing regressed. And then at this point, we go ahead and get the approval to move it to production. Or what if we have some kind of SCAP scan where we are doing control scan to make sure that everything is set correct and nothing regressed. And then at that point, we go ahead and get the approval to move it to the production. And then at that point, we go ahead and validate or verify that everything is in place. And then we roll the new version. So we can do that as part of the DevOps, and that's highly recommended because it's a consistent process. Now again, make sure to incorporate operation and maintenance process into the configuration management plan. It should be part of the configuration management process. So it has to be in the plan, and we want to evaluate the performance of O&M as part of the continuous monitoring. So we are not making any of the changes part of the maintenance part of. It is just making sure that our security baseline remains intact. So we are doing those periodic assessment, those periodic tests to make sure things are solid. That way we are not getting rogue patches installed, we are not getting rogue bugs fixed installed, and things like that. That might also help us to identify maybe there's some backdoors where there are automatic update installed where they should not be, and we are getting patches from the outside. This will help with all of them. So the bottom line for O&M is to understand the purpose of software O&M, know about regression and regression testing, and also know the O&M must be part of the CM plan.